Hello class. This is a tutorial to help you understand water math, right? And so in your PDF file for one of your texts, this is water treatment part one. At the bottom or at the end of the book, there's what's called the appendix one. This is Introduction to Water Math. And so I want to go through this briefly with you to help you understand a few things that you'll be going over in this class, mathematical wise. Right? And so the first thing I want to show you is table one, which is units and conversion factors. This is very important that you understand this because a lot of these conversions and equivalents you will need to understand in order to do the math calculations as well as answer some of the questions starting on your second quiz, week two quiz. And so the first one is 1 cubic foot of water is equal to 62.3832 pounds. So that is to convert our cubic feet into pounds. If we want to convert gallons to pounds, it would be 1 gallon of water, 8.34 pounds. 1 liter of water is 1,000 grams. 1 milligram per liter is the equivalent to 1 ppm or parts per million. This is micrograms. That little U right there stands for micro. So 1 microgram per liter is 1 part per billion, ppb, and then so forth. So make sure that you learn this chart. Flashcards, if you have the flashcard app on your phone, that works really well for learning different equivalents. So these you'll need with you for each of the weeks, okay, for this particular class. So make sure that you learn them and understand them. Then we have simplifying fractions, okay? I'm just gonna go through some of these things briefly because some of these things I am sure that you've already learned in your years of education, but I just wanted you to refresh your memory on simplifying fractions. That's something that you'll be doing math-wise in this class as well. And so if we had 2/4, the common number between the two of these, or the common multiple, is 2. And so if we divide both numbers by 2, you would be left with 1/2. And so 2/4 reduces to 1/2. So pretty straightforward. So you can go through those examples. Also look at division. This is another way of simplifying fractions. So you can go through that information. Multiplying fractions is something we do a lot because what we're trying to do is, when I showed you the table one where you have the different equalities, you want to go from one particular equality to another unit. We call these units. These are the words that are after each of the numbers. So this is 2 square feet, 3 feet, 1 second. And so all of those are your different units, cubic feet, seconds. And so you want to convert, which is our ultimate goal for these different problems, to convert from one unit to a next. So it's important that you understand multiplying as well as dividing fractions, because when you're converting, you use what we call conversion factors, and those are simply fractions, okay? So we have dividing fractions. I want to review this because this may be something when students deal with fractions, usually they try to stay away from fractions because it has a bad stigma that they're too difficult to understand, but it's not that bad. And so if we had 2/5 divided by 1/2, when we are dividing fractions, what you want to do is you want to change your division to multiplication, and the second fraction, you're going to flip it, okay? That's called taking the reciprocal, but it's simply flipping it. So we have 2/5 divided by 1/2 is the same as 2/5 times 2/1. So everything at the top, you're going to multiply, everything at the bottom, you multiply, and you simply get 4/5, okay? So look through those examples so that you can refresh your memory on doing that as well. And then we look at decimals, because decimals and fractions We are just a conversion of a fraction. And so if we had 0.1, it's the same as 1/10. 0.01 is the same as 1 over 100. 0.001 is the same as 1 over 1,000. 0.0001 is 1 over 10,000. Okay. And so those are just some examples. And then rounding. Anytime we are rounding, okay, we always look for the lowest number as significant figures, we call them, or the one that has the lowest numbers here. And so we have 2 times 2, that would simply be 4 because each of those numbers has 1. 2.0 and 2.0, it would be 4.0 because each of these numbers have 2 numbers. If we had 2.0 times 2, we would have 4.0, but we would simply round that to a 4, okay? And so those are some examples of rounding. But what I want to get to is using unit dimensional analysis because this is very important when we're doing calculations for our water treatment class, as well as when you take our wastewater treatment class. You will see conversions in that class as well as a water distributions class. And so understanding unit dimensional analysis in this first class will help you, okay? And so a few things, CFS, because we do a lot of abbreviations, so it's important to understand what these abbreviations represent. So CFS represents cubic feet per second. GPM stands for gallons per minute. MGD stands for millions of gallons per day. And AFY stands for acre feet per day. Sorry, acre feet per year. And so when we're looking at dimensional analysis, what that means is that we are converting from one particular unit to another unit. For example, if we are given a number in seconds and we want to convert it to days, we start with seconds and then we multiply it by the equality between seconds and minutes. As you can see, the seconds are on the bottom here. And we do that because anytime we have a unit on the top and then the same unit on the bottom, we can cross those 2 units out. And so then we have minutes, so we want minutes to go on the bottom, so we can cross those minutes out. And then we have hours. Hours we want to cross out, so it goes to the bottom. And then we get to days. So let me show you what that crossing out looks like. And so we start out with seconds. Our seconds go to the bottom. When we cross them out, all we're left with is minutes. So then we cross out our seconds. We can cross out our minutes. We can cross out our hours, and we end up with days. So that's how we go from seconds to days. Whatever unit is not canceled out, that is the unit that we are desiring. So it's very important that you set up your problems correctly. All right, so let's look at a particular example. All right, so if we have our cubic feet per second and we want to go to gallons per minute, okay, CFS to GPM. And so in order to do that, we're going to start off with 1 cubic feet per second. And we're going to go from seconds to minutes because eventually we want to get to minutes. So our seconds are on the bottom here. They're on the top here because we want to cancel those seconds out. We know that there's 60 seconds in a minute, all right? And so that's our first step. So the seconds cancel out, we get minutes. That's what we want, okay? So when we do this equality, we have 60 cubic feet per minute, but we want gallons per minute. So now we've got to get rid of the cubic feet and go to gallons. So 1 cubic feet is the equivalent of 7.48 gallons. And that we got from that table 1 that I showed you at the beginning of this video. And so 1 cubic feet per second times 7.48 gallons per cubic feet, we have 7.48 gallons per second, okay? And so now we have our 2 equalities. We want to put this all together so that we can get our gallons per minute, all right? So we start off with 1 cubic feet per second. We want to get rid of the seconds, so we go 60 seconds per minute. We want to get rid of the cubic feet, so it's 7.48 gallons per cubic feet, and we get 448.8 gallons per minute, okay? And so there's another example here. I would suggest that you go through these examples, make sure that you understand how to do the conversions, okay? Then we get to area. And so for our area, it depends on the type of shape that we're looking at, what our area is. So for a rectangle, it's length times width, that's our area. For a circle, from one point to the other point of a circle is known as the diameter. So to find the area, it's 0.785 times d squared, where d represents our diameter. For a trapezoid, we have our base here. This is base 1, this is base 2, and this is our height. And so the area is equal to base 1 plus base 2 divided by 2 times the height, okay? And then there are examples of calculating our areas, because when we're talking about water treatment, generally we are looking at different containers, and we have to look at the area of the container to understand how much water that we need to treat, as well as certain treatment procedures. And so it's important to understand the area for that purpose. And so go through this math section of your appendix 1. Again, this is in your water treatment part 1 text, and it's at the very end. Let me scroll back down. At the very end where it says appendix 1, introduction to water math. Very important that you go through this, understand it. If you have questions, please make sure that you ask your professor to give you help. Thank you.